you just have this avalanche of data. And it's not just about, okay, the cost is high, but also how do I maintain reliability in the face of that rapid change?
Don't forget, there's an AI networking summit coming up, and you're invited. So go to the onug.net website to get your tickets now. So, and also if you're on YouTube or Spotify or any of the places where this podcast is being broadcast or streamed, make sure that you hit like or subscribe to it. Thanks. Jad Naous. Welcome, Jad. So excited to have you on the pod.
Thanks, Nick. Excited to be here.
Yeah, great to have you. Actually, I've been looking forward to this all day because we're going to dive into like an area that that has, over the last like 10 years or so has kind of taken on an industry sector of itself, and companies have been building their own spaceships, for observability and also for security, data lakes and so forth. So we're gonna dive into that. But I thought before we start, I'd love for you to kind of give a little bit of background, on your personal career journey and kind of what brought you to Grepr. So obviously you're founder of Grepr, and so we'll get to talk about that in a second. But kind of just give everybody a little bit of your background, so everyone gets to know you a little bit.
Yeah, sure. I've always been a person who liked to take the path less trodden, I guess. So before I founded Grepr, I was at a company called Imply, where I led product and engineering there. Grew the team from about 12 people to over 90 across product, engineering, infosec, design, etc. And the company went from less than, I think maybe about 100 million when I first joined to over $1 billion in valuation by the time I left, which was a really fun journey. That company is still doing great. They're the company behind Apache Druid, a real-time analytical database. And then before that, I was at Andreessen Horowitz for a couple of years as an investor, but ultimately really decided I much prefer working in a team, building together, putting a brick on top of another brick, and actually eventually getting a wall. Yeah. And VC is much more like farming and lots of schmoozing and networking. That's not my particular cup of tea. And then
you do
before
okay
that, before that, I was at AppDynamics. So AppD was an observability company. They were the first company to come up with distributed tracing, and they did really well. They became a unicorn. They got sold to Cisco a few days before the IPO for a lot of money. I was a Cisco employee for one day and left. I was there for about 3.5 years. They grew from 200 to 2,000 people. It was a wild ride. Before that, I started a business actually based off some of the research I had done in my postdoc. And I do not recommend anybody start a business right out of school. It's just, especially if you're going to be selling to in B2B, like B2B businesses right out of school, it's just hard. Yeah, the technology was too early. And then before that, I was in school for too long. I did a PhD and then I did a postdoc.
Yeah. Awesome. Well, great journey. And, but I do want to touch on the starting the company right after school. So, so like when you come out of school, you have a lot of kind of understanding, kind of technical understanding, I think. But like, B2B is really tough for the non-technical reasons. I'm not sure if that's really what you're leading to, it's about relationships and about building trust, and contracts, there's just a lot of kind of non-technical things, to kind of get into the enterprise, or the B2B to marketplace. Is that kind of what you're alluding to?
Yeah, exactly. There's just actually selling to, we sold to Cisco a $3,000 deal. And that was the only deal that we actually closed. But just the mechanics of trying to actually get even just that small thing working was just ridiculous. Yeah. And then, to me, it was a shock. I was in school all my life and kind of trying to figure out the ins and outs and, I didn't know there was something called procurement. I didn't know that there was,
Yeah.
all this
Right.
stuff that you have to deal with, that like legal paperwork can take months and, things that you don't understand, but also what it actually takes to sell into the enterprise, the level of trust that you have to build, and
Yeah.
all the approvals and the champions that you have to build within an enterprise to be able to win a deal. It's just not something I would wish upon someone right out of school.
It's an acquired taste, as they say. It takes it's
Yeah,
like
you have to acquire it first.
yeah, it takes time to kind of build those relationships up. Okay, well, all right, great. But so you've done that with App Dynamic and also with uh,
Imply.
Imply. Yeah, for some reason I was thinking Intuit. Yeah, Imply. And I'm sure you saw a lot over at A16Z, as well, and just exposed you to a lot. So you're, a little bit older, much more wiser, and so now you're doing Grepr. So let's talk about Grepr. This is, like, I didn't know you before you started doing, Grepr, and so this is actually an exciting company for me because I've seen kind of the explosion of the observability marketplace in terms of like the spend, and also on the data lake spend. Like wherever you have kind of alerts, alarms, telemetry, the amount of data that is growing. That if you're not in an operational role, you never see. But if you're in some kind of an operational role, like NetOps, secure SecOps, observability, and so forth, you see this, and it is a massive amount of data. Like, it's like I remember in going back to Intuit, is that Intuit was basically, and this was probably like in 2018, they were kind of like logging, a couple of petabytes, a month, I think it was. And they were spending, a couple of $1 million with Splunk, and that to them was unsustainable. So I think that's really that's so that explosion of data, and so how can you kind of reduce the amount of kind of overlap and redundancy that's in a lot of that, especially log data, and really just get out the signal without, and especially for regulated entities, you need to maintain, the ability for the regulators to go back in and make sure you're in compliance. So anyway, I hope I captured that kind of correctly around the initial use case for Grepr. It seems like you guys are now in a space where the numbers I've seen are kind of astonishing, and it's like a 90% reduction in the storage spend for some of your customers. But let me give the floor to you and for you to talk about it. Okay.
Yeah, thanks. Yeah, I mean, you captured most of the gist of it. It's funny you're saying that Intuit was collecting some 2 petabytes a day, a month. We're working with a customer who has a petabyte a day,
Yeah.
a day,
A
right?
day. Yeah.
And that's the extent of, and now even smaller startups, we're seeing them easily generate a petabyte a month. To us, it's shocking how much data people are generating and very
Mm.
often not even looking at.
Yeah.
And so when I actually left Imply a little while ago, I started talking to a lot of engineering leaders about the problems that they're facing and what they wanted to solve, what was top of mind for them. And everybody would say cost.
Mm.
And that was about 2 or 3 years ago. Well, a little more than 3 years ago. And then I started looking at what people are spending money on. And of course, AWS or whatever cloud infrastructure that they're using would be top. But then they were spending 10 to 20% of what they're paying AWS on observability, like
Uh,
Datadog or Splunk
mm.
or whatever, which was an insanely large tax. And what's happened over the past maybe about 15 years or so is that we shifted from these monoliths to microservices.
Yeah.
And what that means is that for every new feature that you're building, you're usually creating a new service, standing up a new service with new pods, new containers, new Kubernetes nodes, new infrastructures and VMs that are running it, interconnects and network and firewalls and so on, in order to kind of bring up that service. Now, everything has become really easy to bring up and automate. And so it's become very quick and easy, and that's ultimately what everybody's been building. This just explosion of microservices. It's very typical to see hundreds or thousands of microservices that are working together to implement an application.
Yeah.
And when you actually have to do this kind of full stack, every layer of that stack is now generating observability.
Yeah.
You're not just adding some new API call to some service that exists. You're actually now creating a new service with infrastructure, and each layer needs observability. And so now you've kind of multiplied that volume of observability by the number of microservices. So that's the first trend that we saw.
Yeah.
Then the second trend that came in was observability itself became ubiquitous. Now, there's no engineer today who would start an app, who would start building something and make it available to their customers without actually monitoring it somehow and figuring out if it's doing well or not doing well. And so observability has become the first thing that engineers go for, and it's become so easy to add observability. And the depth of the observability tools has gotten so, deep. Everybody is now using observability and using multiple tools to kind of capture all areas of those applications.
Yeah.
So that's the second trend. And now what we're seeing with AI is that the rate of change of applications and infrastructure is just multiplying like 10x. And so all the tools, all the systems, all the things that people used to operationally use to keep their applications reliable are starting to kind of implode because engineers are shipping code faster than ever. New services and new applications are rolling out to production faster than ever. Things that used to take weeks or months to roll out now take days or within a day. And so we're that change of that rate of change has made everything just extremely hard to manage. And so the question is like, okay, well, if you have to deal with all that, what is the solution? We cannot just continuously exponentially collect more and more data and have it somehow be useful. And so that's really the reason we started this company, because we wanted to enable a way to make operations reliable, run operations reliably, without going bankrupt.
Yeah.
Right.
Yeah, and that's great. You're right. Kind of the whole microservers, or introduction of microservices into the industry didn't just bring compute. The orchestration got really simple, but and which is a great tool for DevOps teams and developers. But you're right. You were kind of spinning up infrastructure, and each piece of that infrastructure had their own emitters. So a massive increase in the amount of data there, and now AI is laying another kind of step function increase on that as well. I think it was actually Tom Gillis at the last conference that we hosted. He was basically saying, I think his projection, I hope I'm getting this right, but I think he was thinking by the end of this year into like next year, expect 100 to 1,000-fold increase, in the amount of data, kind of system data, log data, trace data, that to expect and to be planning for. So, okay, so we have massive amounts of data. You're reducing that data. How do you reduce data so that you get rid of noise, but you hold on to the signal? So you're not throwing away the baby with the bathwater, I guess, is the way to think about it, right?
You wanna know about our secret sauce?
Don't expose anything secret, but what gives you confidence? I guess that you're not throwing away good data, and that you're keeping the high signal stuff.
Yeah. So the insight that we look at is the fact that because you're running at scale, because you have microservices, because the processing that's happening in your applications is kind of repetitive. A user clicks a button, like clicks add to a cart or clicks purchase or clicks whatever. That is a repetitive motion that all users do. And so your logs that are being generated, the data that's being generated is usually repetitive. Unless there's some weird new thing that comes up, most of the time, all the data is just telling you the same thing over and over. This happened, this happened, this happened, this happened.
Yeah.
And so the insight here is that most of the time people don't care about these messages. They just want to know, is it still running? And so you don't need to know every single button click that the user actually clicked, or you don't need to know every single time a service a load balancer says I'm up, I'm healthy, or whatever, right? You just want to know when things go wrong, and
Hmm.
you want to know when, in general, things are going well, or things are fine. And so if you think about that, what does that mean? That means that what we need to do is, for all the repetitive data, we need to compress it and say, well, here's a summary of this repetitive data.
Mm.
And anything that's novel or unique or different or interesting, you kind of want to pass through.
Mm.
And so that's really the core of our technology.
Yeah.
And so what we do is we identify so for logs, we support logs, and traces is in beta right now. We are working on metrics kind of coming soon in the next few months. But for logs and traces, the way it works is we identify what are all the patterns in your application. For logs, what are all the log patterns? For traces, what are all the execution paths in your
Mm.
application? And then we bucket those and we say, okay, these are the patterns that exist. And we keep track of the volume of data that's passing through for every pattern. And then we pass through the data as it's coming in. So we don't do any aggregation. It's only when we detect a particular pattern or a bucket or something like that becoming noisy, when we've already sent enough data for that pattern, when we
Mm.
say, okay, I think at this point we can just summarize the remaining of it. And so at the core, that's what we do. You end up with all the interesting, low frequency, unique, different, novel data passing through. And anything that is kind of aggregated, repeated very often, just gets aggregated and compressed.
Yeah.
And with that, we see over 90 to 95% reduction kind of right out of the gate
Yeah.
in terms of volume. And for the customers that we have deployed, they almost never go back and try to say, oh, I don't have this data. Can you send it back to me? But
Yeah.
even if they do, one thing that we do is we also store all the raw data into Iceberg, into a low cost into a low cost, basically, data lake. And so if they ever wanted to go back to the original data, they still have it. So even with all that reduction, kind of going down to the more expensive hot store tools that they're using, if they ever needed, or they needed something that was aggregated or summarized or something like that, they can always go back to the data lake and fetch it.
Yeah. Okay, awesome. That's such a great explanation. It kind of reminds me of like kind of the earlier days of video compression where like you would kind of look at pixel to pixel and you would only the first generation of compression was just to transmit changes, and so you keep the whatever if a pixel doesn't change, then you don't transmit anything. You keep it there, where here you're really identifying, you're learning about the application and the patterns of the logs or the traces, that are coming out of it. And after you see enough of that stuff, you can kind of filter that out, and it's only when the pattern really changes do you actually, transmit, or kind of do you transmit those? Is that kind of, in a kind of a nutshell,
Yeah, you got it. I mean, that's exactly what it is. Like,
Yeah.
why do you need to know that the service is up? You
Yeah.
only need to know when it's down once you know that it's up. So that's
Okay.
really the idea. Yeah,
Okay,
absolutely.
that's great. And boy, if you're doing a petabyte a day, and you're reducing that down by 90%, it's like, it's still 10% of a petabyte is still a large amount of data, but it's better than 100%, of it. So congrats, on that level of compression and fidelity, as well. So let's start to, so I know you're kind of working, I know you have a group of really great customers kind of working on that, or consuming that in an operational role. I'm not sure if you can mention anybody. If you can, feel free. Um, but I think I want to start to talk about, once you have, kind of, the Grepr kind of compression system in place, that's, you're kind of like incenting operational teams and observability teams to say, hey, listen, we can really help you reduce a lot of your cost and your storage requirements as well, or your cloud storage requirements as well. But also, it's like now you're building on top of that, and that's really where your kind of AI integration for observability comes from. So now you have this kind of pattern based, data streams that are coming in. You've eliminated a lot of the noise within those systems. So, how do you now leverage AI there, especially for like, in regulated entities? There's kind of like, context awareness is really important, PII handling, maybe anomaly detection, is another really good one, especially, around, missing logs, maybe the like
Yeah.
anomalous, is another one. So when we talk about that, so it's AI integration into observability with these new kind of pattern-based data streams.
Yeah. So yeah, I mean, I'm happy to mention some of our customers. We have 7-Eleven, FASA, Jitsu are some of our public customers. Site Improve is another one. So we have a few customers relatively large, and everybody kind of the POCs usually are pretty quick. They're like they try it out. It's 4 weeks, 6 weeks, and they're like, why are we not using this right now?
Mm,
Um, but ultimately, like you said, I mean, if you kind of go back to the original problem I was setting up, it's that you just have this avalanche of data, and it's not just about, okay, the cost is high, but also how do I maintain reliability in the face of that rapid change? And how do I make sure that I don't just continuously bring down my environment as I'm moving fast?
yeah.
And there's been a lot of companies that have started that are doing the AI SRE thing where, hey, if something goes down, you can use this tool to go and troubleshoot and figure out what the root cause was. And they help. They make it a little bit faster to kind of come back. But the real thing that we want to get to is a way to make operations as autonomous as possible by preventing problems and issues from rolling out in the first place,
Mm,
or detecting when things are misbehaving and remediating them before a catastrophe strikes.
mm,
Ideally, that's what you're trying to do, not just, hey, let's go and troubleshoot after the fact. And
yeah.
so this is where we sit. We are going on the front end of this. And what we want to do is we're building this, the first proactive AI SRE agent. And what that means is that it's going to monitor your system, your data feeds, your streams, and understand what are the semantics of the data that's passing through. And because we can understand when there's new data, when there's new patterns, new behaviors emerging in your application, we can really just focus on those instead of trying to just consume the 100% of those logs, and then ultimately, really, it's not going to be feasible.
Mm,
And so we consume the new patterns of behavior that appear in your environment, and we monitor them, and we ask an LLM and an AI to help us determine what are the semantics of those behaviors. Are they problematic? Is it a threat? Is it something going down? Is it a business logic problem? So one of our demos, we're showing, hey, usually when there's a problem with kind of a transaction, we roll back the transaction and we refund the customer if there was a purchase.
mm,
But in this particular demo, we actually skip the refund part. And so this is a business level problem. But
yeah.
because we understand what is the normal behavior, we can now say this is abnormal behavior. We've actually skipped refunding this particular customer.
Mm,
That's mind blowing. Like that's not something that exists today or that you can actually do. This kind of void, this gap, this missing thing is not something that people have done before. And the other part of this is that you're setting this up not based on explicit rules saying like monitor this particular transaction and see if you see this one and then see that
yeah.
one, right? Like you're actually asking an AI, hey, monitor for anomalies. You're not
Yeah.
asking it to monitor for specific rules. And this is really the
Yeah.
core thing that's new, that's different. In the world of today, all we're doing is basically after a catastrophe happens or an incident, we're going back and adding rules.
Yeah.
You're at that point, all you're doing is you're basically codifying what already happened. You're being a historian. You're not really thinking about, okay, well, what do I do about all the stuff that I haven't seen yet? So
Yeah.
that's really where we sit and what we're targeting.
That's really great. I love the term kind of like patterns of behavior, because that's really what you're kind of learning what are the appropriate patterns. You're eliminating the noise from that. So you really kind of get at, how the application is supposed to behave and what that pattern is. And then when you see deviations in that pattern, then you could really kind of leverage AI. And it'll be interesting too. It's that you would think that you're in the data pipeline And so that pipeline could go to an observability team, it can go to a security team, it can go to a networking team. And so you can do correlation between, networking and security and observability. So if they're, whether it's kind of threat related or whether it's performance, related, you should be able to kind of see that. And I think really what you're building now is kind of the tools for the infrastructure to be alive.
Exactly.
It's a
I love it.
living,
Yeah, exactly.
yeah, it's really, it's not just like, hoping and praying and monitoring it and making sure it doesn't go bad, but you actually now have a living, infrastructure, that
Right.
can now speak to you, and tell you, hey, you really got to watch this, or, give some recommendations as to like, you need to quarantine,
Yeah. But
these systems and so forth. But
yeah, absolutely. But it's not just about alerting, right? It's not just about, hey, look, there's something going on. It's also about taking the first few triage steps.
yeah,
Like, okay, we've figured out this is a particular problem. Can we now figure out also what are the particular initial triage that we can do? Is this something that I've actually seen before? Do I think that restarting this particular service is going to solve this problem? Should I restart the service automatically? And
mm,
kind of being able to give that AI and that LLM some initial remediation steps that it can take,
yeah,
so that maybe you don't have to wake up an engineer at 4 a.m. in the morning,
yeah,
right?
yeah, yeah. That's like super great. Yeah, you can't do any of this today with existing
No.
with existing tools, and that's actually, that was going to be my other question, is that like, all right, what can you do today, with Grepr that you can't do? So like right now it's you're I wouldn't call it a pivot, but like, the journey that you're on, is to first, get control over, the tsunami of data that's coming out from all the emitters, and get that into a controlled scenario. And now but you do that, and not only are you adding the value, you're reducing the amount of data, but like you're actually now categorizing it in a way that is highly leverageable, for AI models. And that's a piece I didn't realize until like, this moment. Yeah, that's great. Really congrats, Jad. That's going to look forward to kind of see how this rolls out. I think the other thing I thought, as you were kind of mentioning some of the companies, what's really interesting about that list that you just talked about, it's both kind of cloud first companies and traditional companies. So like, when you mentioned 7-Eleven, yeah, I don't think 7-Eleven is a 100-year company. It might be a 50-year, company, but that's kind of a traditional enterprise, along with all the financials and um, the pharmaceutical companies, healthcare, industries. These companies have very long, um, operations of business. They have a lot of structure in place. They have a lot of regulation in place. So it seems like you learned a lot, from that first time when you left, school to like into the enterprise marketplace on how to deal with, these companies. So you're into it. So like, I guess the only point I'm making is that it's a nice, you're not just focused on where the Grepper solution isn't just for like cloud first companies. It's or just for the large enterprise or enterprise companies. It straddles both markets, and that's
Yeah.
good for you. That's a great, that's a good TAM play, for Grepper.
Yeah, we've got a bunch of also, the companies that we have that are currently 100% customers are kind of, we've got some big ones, some small ones, and now we're kind of also getting some mid-sized ones over time and kind of building out
Hmm.
kind of the full spectrum of companies that are really using Grepper to solve this problem. And like really, I'd say that the biggest story here is this: like, imagine you're running an operations team, you're the head of SRE, you're responsible for the reliability of your systems and applications,
Yeah.
and so that's your number one mandate. But your customers are the engineers, the developers who are actually doing the troubleshooting and who are actually resolving issues and so on.
Hmm.
But you also have a limited budget to deliver on that capability. And the engineers hate change. Like they will
Yeah.
not. It's very hard to convince them to just drop their existing tools and use something else.
Mm.
And even if you decide to drop those tools and go to something else today, it's not clear that you actually get the ROI that you're expecting.
Mm.
And so if your CFO comes to you and says, you're spending too much on this tool, what options do you have? There's really no options. You could basically maybe spend a couple of full-time resources on continuously toiling through rules and trying to figure out what data to send, what data not to send, and how to send it in what form. And then maybe upsetting all the engineers because all of a sudden you've dropped all their data and they are now, and at incident time, they don't have access to the data that they actually need. And so they're basically stuck between a rock and a hard place. They're saying, well, I need to cut spend, but I can't risk my job by increasing risk. And so you kind of have no recourse until we came along. And what we say is like, hey, you don't have to make that choice. What we'll do is we'll help you solve this problem. We'll give you this knob that makes it really easy for you to make a determination on how much data you want to send, how, in what form, what signal you want to keep, what noise you want to eliminate, and so on. And it deploys in 30 minutes. You see the value immediately, and you can tune it over time with the understanding that you always have a backstop, which is the data lake. The data is always there, so you never lose anything.
Yeah.
And so it's a win-win on all fronts.
Yeah.
And what we often find is that people just don't believe it. Like, how can that be possible? Until they actually try it and see.
Yeah. So is that like, some of the maybe surprises that you had from some of your early customers? I think you've seen the operational cost savings, but the operational impact, as well. So like that's kind of like a productivity cost, trade-off that you were just describing. Is there any other kind of operational impact that you've seen?
Yeah, I mean, one of our customers was saying, hey, we actually had a full-time person whose job is to go after new log patterns or expensive log patterns that we're seeing in production and trying to convince the engineering teams to take some time off to turn those off.
Oh,
That
oh
was
God, that was a
full-time
full-time
job.
That was a full-time job. Oh my God.
Right? I mean,
that's a terrible job.
nobody wants to do that job.
Yeah, that's for sure. My God, it's a dirty job, but someone's got to do it.
Exactly. Nobody wants to do it. And,
okay, so that's
yeah.
like, okay, so that's like grief elimination. So that's like one value prop, operational impact. What else? Operational impacts.
So what we see is that people will now they're able to read logs. Like, very often, one of the issues that we face is when you have a stream of billions of logs going in, and you kind of want to really understand what's happening in the stream. Like, I'm going to read through, I want to understand what's happening step by step.
Yeah.
It's impossible when you have billions of logs.
Yeah.
But when you actually use Grepr, it filters out a lot of the noise and the repetitive stuff, and it just keeps the things that are unique or different. And so you can actually scroll down through a particular time period and be able to see, okay, well, is there something here that's interesting just by eyeballing it?
Yeah.
And that's not something that anybody was able to do unless they were running in a very small environment. But now, to a certain extent, you can.
Awesome.
And so we see that like this kind of elimination of noise is helpful in a lot of cases as well.
Yeah. Yeah. Very good. Okay. Let's like kind of like try to look a little bit into the future. This stuff, is happening like so fast. It's like I have one of our CTOs kind of got me into like, I hate the term, but I guess I'll use it, vibe coding, so it's like I have like, Grepr windows, I got, Docker desktop, it's like, the Claude, I think I said Grepr, I meant Claude, I got Claude desktop, going, terminal windows open. So it's like, I've been using a lot of, these AI tools. And if we kind of think about, I think agentic has like some problems in the large enterprise, like, from a governance and a control and security point of view, which I'm sure we'll be able to solve, over some time. But like, even with my, data point of one, like I'm seeing kind of almost like, Anthropic kind of releasing like, multiple releases a day. So it's like the pace of this stuff is pretty astonishing. Faster than anything that I've ever seen in my career path. So what's your kind of crystal ball like? I think one thing that when we were thinking about when we were talking earlier about containers, spinning up and spinning down, that that's going to be nothing compared to the agents spinning up and spinning down, and the infrastructure that they're going to create, as well. So I think I think it's pretty well agreed, that the amount of data isn't going to slow down at all. It's anything, it's just going to continue to increase. So if we kind of put ourselves into like a world, where we have a lot of agentic systems that are in, how do you see now Grepr, participating in a space where you're doing automated troubleshooting, these systems, you gain a lot of valuable, insights into the business, the tools that you're using and also enhancing other tools are now providing, better reporting. So I guess the bottom line is that if we think, 3 to 5 years out, how do you think this space evolves, and what's Grepr's role in that?
Yeah, I mean, that's really what we're building towards, right? I see the future of operations as being kind of much more autonomous than what it is today, and the role of the SRE migrating from being someone who is looking at dashboards and trying to kind of troubleshoot down what the root cause is, or setting up alerts and setting up monitoring and logging and so on, to someone who is actually building what I like to call reliability applications, or maybe we can call them proactive agents. And the idea being that they're making decisions on, well, what is actually needed to make a good decision about what is happening in the infrastructure.
Hmm.
And what they're doing is setting up intents. They're explaining to the agent some things about their infrastructure, about their applications that are running, what they want to see out of them, what are the goals, and kind of connecting things that should be connected together to give those autonomous agents the ability to run infrastructure and operations.
Hmm.
And so that's really where I see that going from that layer. And then on top of that, what you're actually going to be running are applications that are completely built by an agent, kind of top to bottom, kind of a black box
Hmm.
that is really, nobody actually has looked at the code in particular, but they have described what the application should be and validated it across using natural language requirements. I
Hmm.
don't know if you're familiar with this language called I forget what it's called, whether it's called Gherkin or Cucumber. I think it's called Cucumber.
I've heard of
But
Cucumber. Yep.
yeah, so it's a way to write tests using natural language.
Hmm.
So a product manager can basically specify their tests, what the functional requirements for an application is using natural language. And I see that this is going to be the way people are going to build applications and deploy them in the future.
Hmm.
I mean, today, when we first started coming up with first procedural languages, then object-oriented languages, functional languages, and so on, like each one of these is a new paradigm, and I actually see coding through an agent as a new paradigm, and I imagine that there will be a new, more structured language than just natural language, which is what we have today, that
Hmm.
allows an engineer or developer to describe much better what the requirements are, how something should work, and be able to build much faster with less mistakes.
Yeah.
So that's kind of how I see things over
Awesome.
time.
Yeah, and we start with pattern behavior, and that's something that is consumable, by AI, and then we're kind of off to the races for autonomy infrastructure. And then the role of Knox and Socks, changes pretty significantly, which is a good thing. Yeah. Have you So are you mostly selling into kind of SRE folks, DevOps, folks, or do you interact at all with like folks in the network operations and security operations teams?
So we've generally been on the SRE and operations side, not
Mm-hmm.
well, the platform teams usually, less so security and network,
Mm-hmm.
just because we haven't really tried to hit those groups yet. I think that there's definitely a lot of use that can be, or there's a lot of value for Grepr in the network ops space, because most of the time these systems are just doing the same thing over and over, and you're kind of trying to aggregate data as opposed to necessarily trying to look at every individual flow, for
Yeah.
example.
Hmm.
On the security side, there's absolutely a lot of use cases which are going to get much sharper as we build out our proactive agent. So one of the things that we're doing is the ability to collect and kind of create a trace from your logs. So you can say something like, hey, this is a particular user logging in.
Hmm.
And you can understand that this is the user by tracking this maybe transaction ID across multiple log messages, or maybe track this IP address across multiple log messages, and kind of stitch together a story for every user who is logging in. And
Yeah.
then look at the different patterns of users logging in, or maybe authorization requests and so on, and then try to determine if this is an anomaly or not an anomaly.
Yeah.
And so there's a lot of use cases on the security side that we're also starting to explore now, where what you want to do is you want to discover threats that you don't have rules for,
Hmm.
and try to mitigate them. So that's really what we're starting to look at.
Yeah. Awesome. Hey, Jad, this was like really great. For folks who want to know and learn more about Grepr, it's grepr.ai, correct?
Yep, that's
That's the
correct.
website. Okay, great. And I know you guys have a really great demo. So we're going to put that into the notes, so people can kind of consume that, at their leisure. So,
Absolutely. Yeah. Thank you, Nick. It was
Jad,
a
thank
pleasure.
you. Yeah, actually, that was a lot of fun. I know a lot more about Grepr than I did 45 minutes
Before.
ago. So great. Thanks so much.
That's good.
Thank
That's
you.
the goal.
That was. Thanks. Thank you.
Yeah, thanks for taking the time.
You're welcome. Thanks everyone for plugging in as well.